Chord properties of a circle. In our earlier videos, we defined what a chord is. A chord is simply a line that connects any 2 points of the circumference. So it can run from here up to there, or it can run from here up to there. Any 2 points of the circumference is connected by a line we call a chord. This is Kisembo Academy, and thanks for tuning in. We'll look at the first property of a chord. Looking at this, we are saying that the perpendicular bisector of a chord of a circle passes through the center and bisects the angle subtended by the chord at the center. We are having a chord here AB. So if we are having a chord AB, the perpendicular bisector of this chord will pass through the center. And this is the perpendicular bisector we are talking about. It means that when this line is coming, this perpendicular is dropped from the circle's center to come and bisect this line or divide it into two. It means that AD, which is that, is equal to DB. So this length is equal to that length. Since this perpendicular bisector bisects this chord, it means that this angle up here is the same as that angle. They're going to be the same. The line joining the midpoint of a chord, which is the perpendicular bisector we've talked about in the previous property, this line bisects this chord into two. Our right up here says that a line joining the midpoint of the chord to the center of the circle is perpendicular to the chord. So this is just a minor detail of our previous property, that this line that is going to bisect this chord into two is actually meeting this chord at 90 degrees, or call it a perpendicular bisector. So CD is perpendicular to AB, and therefore D is the midpoint of AB. And if D is the midpoint of AD, it means that this portion AD is equal to this portion DB. Next property says, if two chords of a circle are of equal length, then they are the same distance from the center of the circle. And in our illustration, we are having chord AB, we are also having chord DC. If these two chords are of the same length, it means that they are going to be having the same distance from the center. So it means the distance from here to here, FC, is the same as the distance from C to G. So it also follows that the distance from A to F is the same as the distance from F to B, and also the distance of D to G is the same as the distance from G to C. Now our next property is just the reverse of this. In our next property is telling us that if two chords are the same length, then they have the same distance from the center. So if we're having chord AB and chord ED, and these two chords are the same distance, so it means, they're the same length, then it means that the distance they are from the center is the same. And so in this case, FC is the same as CG. So we'll work out this example. Now, as we are interpreting some of these numbers, we need to interpret them basing on these properties of chords we have explored. Find the length of the chord of a circle of radius 5 centimeters, which is 3 centimeters from the center. So we are having a circle like this with a center. And now they're asking us to find the length of the chord. Let's say this is the chord. They want the length of the chord of a circle whose radius is 5 centimeters. So the radius of the circle is 5 centimeters and it is 3 centimeters from the center. So the distance from here to there is 3 centimeters. So the chord is 3 centimeters from the center, but it's having a radius. Remember, this radius, this distance from here to here is also 5 centimeters. The radius of this circle. This is the circle's center. So if they want us to find the length of the chord, we know that this, if you're to look at this and extrapolate it out, you find yourself having a right angle triangle. We said in our earlier properties that a line that is connecting, when you drop a perpendicular from the center of the circle to the chord, it is going to divide this chord into two. So if it is going to divide that chord into two, it means that the distance here is the distance here. So if we want to find the length of the chord, it's as simple as finding the length of this part, then we just multiply it by 2. to be able to get the entire length of the chord. So here we are having, this is 5 centimeters, this is 3 centimeters. For us to be able to get this length, let's call this length x. So we use Pythagoras theorem to get this length. X squared plus 3 squared is equal to 5 squared. So it becomes x squared is going to give you 5 squared minus 3 squared. We shall end up getting our value of x as 4 centimeters. When we get our value of x as 4 centimeters, it means the distance from here to here is 4 centimeters. But we are aware that this is half of the whole thing. So it means that the length of the entire chord is 4 centimeters plus 4 centimeters, which is 8 centimeters. So the length from here to here is 8 centimeters. That's the answer. Two parallel chords of a circle of radius 10 centimeters are of length 12 centimeters and 16 centimeters. Calculate their distance apart. Let's draw a sketch. We have a circle. Two parallel chords of a circle. So we have two chords that are parallel. We have the chord up there and the chord down there. They are parallel, so it means they never meet. Two parallel chords of a circle of radius 10 centimeters. So it means that if this is the center of the circle, the radius is 10 centimeters, are of length 12 centimeters and 16 centimeters. So if this thing here is 12 centimeters, this one down here is 16 centimeters. Calculate their distance apart. So if they want us to calculate their distance apart, this is the distance they want us to calculate. But now if the distance from here to the circumference is 10, it means also the distance from here, the radius, to the circumference here is also 10 centimeters. So if they want us to find the distance apart, it's a matter of getting this distance. We also calculate for this distance, and then we add the two distances, and we are able to find the distances apart, the distance between these two chords. But also we know that when you drop a perpendicular from the circle center down to this chord, this line is dividing this chord into two. So if this whole chord is 16 centimeters apart, it means that the distance from here to here is 8, and this one is also 8 centimeters. Likewise up here, if this whole chord is 12 centimeters apart, it means the distance from here to here is 6, and from here to here is also 6 centimeters. So in so doing, we are able to extrapolate right angle triangles, and our own task is to just find those two heights, and we are done. So if you are to extrapolate that, we have this one is 10, this one is 8, so we call this x. The distance from here to here, we call it x. Then also the distance from here to here, if we are to extract that as well, this is 10, then this is 6, and then we get this distance. Let's call that distance y. So to get the value of x, we are going to use Pythagoras theorem. X squared plus 8 squared is equal to 10 squared. So our value of x here is going to be centimeters. Likewise here, it's going to be y squared plus 6 squared is equal to 10 squared. So to get our value of y, it's going to be, so the total distance of the distance between these two chords, this distance is going to be x plus y, which is 6 plus 8, which is going to be This brings us to the end of this tutorial. Thank you for watching. For more videos, I encourage you to subscribe to this channel and also to share on other platforms. I hope you watch the next video. For Kisembo Academy, this is Arnold Rwangakuramya.